This video will explain the answer to the following question. Please make sure that you pause the video or rewind it whenever you need to review something important. A ladder leaning against the building makes an angle of 65 degrees with the ground and reaches a point on the building 20 feet above the ground. What is the length of the ladder to the nearest foot? The important things you want to pay attention to is the given angle, which they're saying is making an angle with the ground and the point of a building. So here's the ground and here's the point of the building that it's looking at. So that is why the angle is down there, because it's along the ground looking up at that spot. Then it also says that spot is 20 feet above the ground. Since it's above the ground, you have to think of it as a direct height, meaning this will be a right angle here. It is that distance above is perpendicular to the ground. Now you want to find the ladder. The ladder is not placed exactly against the wall, but it's on a slant. It's actually on a 65-degree with the ground slant. So that's why the ladder is labeled the unknown variable. So now that I've explained the diagram, let's get into the two questions you should ask yourself whenever you're approached with these trig questions. The first question, which trig formula will I use, SO, CA, or TOA? To determine that, we need to label our triangle. So go to the input angle they gave you, 65 degrees, go across from it, 20 feet. The height is our opposite side. Go to the 90-degree angle and go across from it. X, the ladder, is our hypotenuse length. Finally, go to the input angle, 65, and go next to it. That ground is our adjacent side. Looking at the triangle, we can see that we're given the opposite, the height, and we're given the hypotenuse, the ladder, in our problem. One of them is remaining the variable, but that's fine. That's what we're trying to solve for. So we're looking for a problem that is involving our opposite side and our hypotenuse side. We can get rid of cosine because it deals with the adjacent side and the hypotenuse, and we could deal with tan because it deals with the opposite and the adjacent side. Only sine deals with our opposite and our hypotenuse. So we know the equation we're going to use is going to be sine of our input angle is equal to our opposite side over our hypotenuse side. The second question I should be asking myself before I really dive into solving is, am I solving for a side or am I solving for an angle? If I'm solving for a side, I want to use regular sine. If I'm solving for an angle, I want to use the inverse sine. Since x is what we need, x is the ladder. The ladder is the outside of the triangle. It is a side. So I know I'm going to be using regular sine. So now we have our trig identity we're using, our input angle, and we need to plug in our opposite, which is 20, over our hypotenuse, which is x. I just wanted to make a little bit of room for solving, so I erased my labeling. And now I have room to put our sine of 65 over 1 so that I can create cross products. 1 times 20 is 20, and x times sine of 65 is going to be x of sine of 65. To isolate x, I need to divide by sine of 65 on both sides of my equation. And now that will allow me to reduce out the sine of 65 and have x isolated. And here I need to plug in my calculator, 20 divided by sine of 65. 20 has to go first because it's on top. Or if you want, you can hit the alpha button and the y equals button, and that will allow you to type a fraction in. When you're doing this, please make sure you're in degree mode. And after you hit enter, you will get your answer. It will be a decimal, but you have to round it to the nearest foot, as it says, which will make your answer 22 feet. And we have that answer as choice number 4.